I hope everyone had a chance to have a short break, and we had a packed agenda with so many interesting sessions. So it gives me great pleasure to introduce Martien Foss, who will be talking about an application that he's been working on using RDF graphs. So when people talk about graphs, there are typically two data models: the property graph data model and the RDF graph data model. And the property graph data model tends to be used for things like analytics, to run graph algorithms, to do reachability analysis, and so on, as we saw in various examples. RDF graphs are particularly useful for data integration, for capturing knowledge about a domain using ontologies, and so on. So that is now what Martien is going to talk about, and he's been working on this for a number of years. He has extensive discussions with various RDF developers, including the RDF development team. He's currently a data architect at Red Force and has over 25 years experience in GIS, data migration, and data integration. And as you can see when he speaks, he's very passionate about this project and the possibilities that RDF Graph has enabled for him. So over to you, Martien.
Okay, let's try to share my screen. So to advanced portion of the screen, share 25.
Yep, I can see your screen now.
Okay. Oh, sorry.
One quick, the resolution, maybe your screen is spilling out beyond the screen seems larger than what.
Yes, let me try again. Is it now correct or not?
I think the bottom part of your screen is cut off a little bit. And now the right side of your screen. So I wonder whether it's a resolution thing or.
Should be. Sorry. Not quite, huh?
Yeah, I still have the bottom part of your slide cut off.
I'll try it again. Now I don't see anything. Somehow things are going wrong. I think I have to log on again.
It's all right. Don't take your time, sir. Bill.
Roger and Melanie, while Martien is working on the slide size, when he starts again, can we do the reintroduction so that we can make a clean recording break for our admin?
Sure. Happy to do that. And while we're waiting for Martien to join back, the little history about RDF graphs is that RDF graphs have been around for, I think, 15 or so years. I think they started off as from Tim Berners-Lee wanting to have a more semantically integrated World Wide Web, and he introduced some of the standards he and his team he was working with. So it's been around for a while. It's a very mature set of standards to work with. Property graphs is, on the other hand, a more younger or newer graph model. It's becoming a hot topic these days. So I see that Martien is back.
Let's try again.
I don't know why we're still having issues with the screen being cut off, but maybe that's okay. Did you just want to turn off slideshow mode? Maybe just do it without slideshow mode. Maybe that might be better. You can control the.
Okay, let's try it. See if I can go back.
And
just one moment, I have to start.
Your computer's got stage fright.
So,
like me playing the piano. Yeah.
Why is it?
Would you like Carrie to use the slides that you sent us, and we could fall back on that backup?
Let me see if I know. You see my screen?
That works. Okay, perfect. This works.
Okay.
We're good. We're in good shape. Let me just reintroduce you again, Martin, so that when we edit the recording, it's all seamless. So it gives me great pleasure to welcome Martien Was, a data architect at Redforce. He has over 25 years experience with GIS, data migration, and data integration. One of the topics he's really passionate about is the power of RDF graphs, and that's what he'll be talking to us about today. So over to you, Martien.
Okay, thank you. So this is all about integrating of data silos with linked data. Like Melly mentioned before, my name is Martien Was. I'm working for Redforce, which is a subsidiary of the TPA group, and I mainly are concerned with data management, things like linked data, data integration, geospatial, and so on. So what's this session about? This session is about an RDF graph, which is mentioned. The purpose of it is to link different kinds of silos together. And we use the Oracle Converged database for this. And on top, we developed our own solution called Lydia, which you afterwards will see in a demo where we have a sewage case we will show you. The technologies we used are from the database RDF Graph, spatial, JSON, relational data, SODA, and REST API. And on the development part of our applications, we have used Jet, which is in fact a JavaScript application, and Apex. To expose all this data to the outside world, we used GeoServer as an open source visualization tool. And there we also have Prodigy, which is an open source tool for modeling the RDF model. This all has been developed in the cloud, in the Oracle Cloud. And just to mention that the longer version will be scheduled in next year in January. So like I said before, the Redforce is a subsidiary of the DPA group. We started in 2016. We are in fact specialized on linked data, especially on the geo part, Geosparkle. And we did our first project with linked data in 2017. Why have we chosen for the RDF graph? First of all, we wanted to avoid, in fact, as much as possible, a data replication. And on the other hand, the RDF technology uses the internet. So that means that everyone, in fact, on this planet has internet available. And with this technology, people can, in fact, query data all around the world if they are granted and authorized for this access. We also wanted to have as much as possible real-time data retrieval. And we wanted to introduce smart geospatial data. This will be shown later on in the demo. And what we also wanted is to set on standards like the W3C standards and the OGG standards. So what common problems do we face if we want to integrate data silos? If you want to have a 360-degree view or want to solve a business case, then in fact you have three main problems. One of them is you have same names with different meanings, like a bank. In one silo, this could mean a financial institution. And in another silo, this could mean a bank in a park. Another one is that you have different names for same meaning. If you have a couch and a sofa, that's an example of this. And the third main difficulty is that you have different structures. For example, if you have a name and address, in one silo, this could be one entity. And in another silo, this could be two entities. So to solve these problems, you can, in fact, use semantic definitions, which put a virtual layer on top of this all with meaning. And the outcome of this all is that you lower costs, lower maintenance, and you can faster realize some business cases, and it is very flexible. So what Oracle has done is implemented in their database a graph, which is compliant to the W3C and OGG standards. So you can use all the Sparkle, RDF, RDFS, and OWL, and Geosparkle things that have been defined. And on the other hand, you have, of course, the possibility to use the existing strengths of Oracle, like scalability, high availability, and so on. So RDF, in fact, operates on subdomains. And as you can see, with these subdomains are, in fact, then connected to each other. And with Sparkle, you have a query language which can traverse over all these subdomains. And with Geosparkle, this Sparkle can be extended so that you also can ask questions in combination with geo definitions, like are some objects in a particular area. So what we've done is we have three applications. One application which is acting on the geospatial subdomain. We have an application which is acting on the asset subdomain. And then we have an application, a viewer, which can be a third-party viewer, which combines these two subdomains. But the viewer is not restricted to these two subdomains. So what preparation did we make? We loaded an existing ontology, which was developed by RioNet in the Netherlands. That was the sewage ontology, which has definitions about kinds of sewage pipes and relations of them towards other objects. And we developed our own geo ontology, which was designed in respect to a map, because the X and Y coordinate, the map is more than an X and a Y coordinate of an object. For example, you have annotations and that kind of things. Then we loaded some relational data, geospatial data and asset data, and converted it into this graph with respect to the ontologies we've loaded. And then on the right side, you see those three applications. On the geo subdomain, we have a JET application, a JavaScript application, which can do maintenance on the geo subdomain. And we have an IPEX application, which can do maintenance on an asset subdomain. And then we have the third-party viewer, which shows both of these subdomains together. Our geo application is data-driven. That means you see all the objects which have been defined in our geo ontology. You will see them in our geo application appearing again. So in fact, we can generate this kind of applications. So here's a summary about things that we have spoken before. And I also want to point out that there will be another TechCast where we will show more of this architecture and functionality. So let's go to the demo. So let's see if I can switch. Stop sharing. I share my screen again. And let's try this one, share. So do you see a map now, or?
Yes, we see the map.
Okay, so first of all, I want to show you the viewer. In this viewer, we have combined both the geo subdomain and the asset subdomain. And if you zoom in, you will see more data of these two domains. And you see here the geometry of a sewage pipe. And then if you click on it, you see, in fact, the asset data which belongs to that asset domain. So our task is, as an engineer, to document a new section of a sewage pipe for both geometry and asset data. So the first thing we will do is we will create a working area. Since this is a multi-user environment, the meaning of this work area is to show other users which also want to manipulate this map that they shouldn't also work on that spot to avoid, in fact, collisions. So let's create a working area. So I chose that object, and I have to zoom in, so okay. And I also want to make an annotation on this area. And you see this is a kind of dummy value because, in fact, this area is not linked to anything at all. So let's save this part in the graph. Now we are going to our asset subdomain, and you also see here working area. So let's make a new entrance. We will duplicate a row, change some values of it. Let's say this is, and we will save this. Now, on the asset part, we also have this data saved in the assets part of the graph. So we have a geo object in the geo part and asset data in the asset part. What we're now going to do is to link these two things, two pieces together. So here's a button, which when I push this one, then it marks this row and makes it available for linking towards geo objects. So if I now choose this in the geo domain, shows this object and say make link, then it says here the link has been allowed and so on. So I will save this in the graph, and now you see here on the annotation that it has copied, in fact, the value from my out of the asset part where we copied the email to this thing. So let's go back to our task. Our task was to map a sewage pipe, and therefore we chose sewage pipe and say sewage pipe and draw just a sewage pipe and make two annotations to it and save this in the graph. So now we have the geometry in the graph, and now we're going to the asset part, and here we also have sewage pipes. So again, just make another entrance by just duplicating, change the date of it to 21, and we have October, and say save. And here these drop downs are directly coming out of the sewage ontology. So these values we didn't define ourselves, but they are directly coming from that ontology that was defined by RioNet. And we can choose a shape, say save. And now again, we want to link, in fact, this asset data to the geometry. So we again mark this part, go to the geo subdomain and say make link. And you can see the link was allowed and created, and now we can save this in the graph. And you will see that there is the material is now on the place for the annotations. So if we go to the viewer and you see that in the viewer, this data is immediately available. So this is all near real time, in fact. So if I click on it, then you will see the asset data, which was being linked towards this geometry. Now let's do some changes. So suppose I want to change this material to, let's say, epoxy, and save this. Now we are going back to our geo application, and we reload the data, and you see immediately this has been changed to epoxy. So it's changing in real time. If we go to our viewer and we refresh things, then you see also that it has been changed to epoxy. And if I click on it, you see also that it is changed. The other thing, what I want to show is, suppose you want to change just the geometry of this pipe. So we make a little bit longer and we reposition an annotation and say save. Soon as the data has been saved, we can go to our viewer, and you will see it immediately has been updated from the graph. Another thing I want to show you is that it's about these smart geometries. So if I'm going to delete this sewage pipe, and you have to pay attention to these annotations, and I say save, then the system knows, because of these smart geo objects, what belongs together. So it knows that it also has to delete these annotations. You see they are disappeared here, and if I go to my viewer, you will see that it will also be, cache has been disappeared. So what else do I want to show you is that suppose you are in the asset domain, and we want to search for a particular manhole. So I chose here manholes, and you see here I'm searching for a particular number with this number. This is just standard Apex functionality you can use. So if I put on this filter, it will search for that part. And now I want to know, where is this object in my geometry? So there is here a button where I can say, put this row on the sticky board. So it has been placed on that sticky board. Now I go to my geo domain and I say, zoom towards that what's on the sticky board. And then I can say, select what's on that sticky board. And here you see again, we have two objects. It's in fact the manhole and the annotation. And that's again this part for a smart geo object. Now let's do the opposite. Suppose I have in my map this sewage pipe, and I want to know what asset data is connected, linked towards this sewage pipe. So I put this on the sticky board, and I go to my asset application. And now you have to pay attention, because the form we are seeing now are manholes. And if I say zoom to that sticky board, it should switch towards the sewage pipes and make a filter on it, so that we now can see that this asset data belongs to this sewage pipe. So I could do the, in fact, the opposite and say again, put this on the sticky board and go to the geo part and say select, and then you see it fits together. This is what I wanted to show you, so I would like to give control back to Roger. Thanks.
Thank you, Martien. There are a couple of questions I'm going to quickly ask. One is, what kind of development environment did you use for this? Did you use Apache Jena or Eclipse RDF4J or something else?
No, it's just plain JavaScript with open layers for this geo part. And for the Apex part, it's just Apex, which where we have made a kind of API so that the developer doesn't have to bother about what's linked data or whatever. He just can concentrate on developing an Apex application.
Right, right. And the back end, they're all talking to Geosparkle.
Yes, the backend is talking to the Geosparkle. That's the only way to get the data out of the graph.
Right, right. And then the next question is, what data modeling tool did you use?
We used Prodigy. I showed that before in the PowerPoint, where we had, can I see?
Right. And
Yes.
yeah, Oracle Graph has a plugin for Prodigy as well. Just
yes.
Are aware. Yeah.
So, but in fact, with Prodigy, we do the modeling and then load this model into the Oracle Graph.
Right, right. Okay, so with that, thank you very much, Martin. Go ahead, Roger.
No, we're just going to say, I never thought it would be interesting to hear about sewage pipes. It's a very practical use, and it's amazing how it all comes together. So.
And in fact, with these viewer, you have control, in fact, over all the data, so you can do all kind of analysis. And we've showed you 2 subdomains, but suppose that you also have a third domain, like financial data, and this financial data was linked towards the asset data. Yeah. Then within the same company, you can use the same geometry to make thematic maps in one department with financial themes and in the other department with asset themes. And everything will be held in sync with these 2 applications or more applications.
Oh, very good. That was really interesting. Thank you very much, sir. Thanks, Martien.
Okay, you're welcome.
Okay. So I think it was a great presentation.